Fire pumps are governed by several codes and standards including NFPA 20, standard for the installation of stationary pumps for fire protection, NFPA 13, standard for the installation of sprinkler systems, and the IFC, or International Fire Code. Generally, fire pumps should be situated in areas where the risk of fire, flooding, or other hazards is minimal. If a location is prone to flooding, measures must be taken to protect the pump from potential damage. For fire pumps specifically installed on piers, NFPA 20 Section 5.2.2.5 states that fire pumps and piers must be positioned above the mean high water level and shielded from the effects of flooding. In contrast, NFPA 13 Section 10.3.2 states that fire pumps installed in piers or wharves shall be located below the mean high water level and protected from flooding. The IFC Section 903.16.1 stipulates that fire pumps should be located above the level of the highest anticipated flood. When determining the required flood level, the potential for storm surge and tidal events should be considered. It is also recommended to ensure adequate drainage around the pump and any emergency generator to prevent flooding. Installing pumps on an elevated platform or within a flood-resistant enclosure are viable protective measures. Electrical components and wiring must be safeguarded against water damage. Regular maintenance and testing are crucial to ensure the pump is operational in the event of a flood. It is important to note that local building codes and fire regulations might impose further requirements or restrictions on the installation of fire pumps on piers. Consulting with a local fire marshal or building inspector is advisable to ensure compliance. Firstly, NFPA 20 addresses stationary fire pumps. This standard provides comprehensive guidelines for the selection, installation, testing, and maintenance of fire pumps used in fixed fire protection systems. It covers aspects such as pump types, drivers, controllers, power supplies, and system components to ensure reliable operation during a fire emergency. Secondly, NFPA 13 focuses on sprinkler systems. While it doesn't exclusively deal with fire pumps, it does address their role within a complete sprinkler system. The standard outlines requirements for water supply, including the use of fire pumps when necessary to deliver adequate water flow and pressure to sprinkler heads. Thirdly, the IFC or International Fire Code offers a broad set of regulations pertaining to fire safety in buildings and facilities. It includes provisions for fire protection systems such as sprinkler systems and standpipes, which often rely on fire pumps for water supply. The IFC specifies requirements for the location, installation, and protection of fire pumps to ensure they function effectively in fire suppression efforts. Each of these codes and standards plays a crucial role in ensuring the proper installation and operation of fire pumps, particularly in challenging environments such as piers, where flood risks are a significant concern. Adherence to these guidelines is essential for safeguarding lives and property from fire hazards. Now let's explore the implications of locating fire pumps above or below the mean high water level, as seemingly contradictory requirements appear in NFPA 20 and NFPA 13. The intent behind locating fire pumps above the mean high water level, as stipulated in NFPA 20, is primarily to protect the pump and its associated equipment from the detrimental effects of flooding. By elevating the pump above the anticipated water level, the risk of submersion is minimized, safeguarding the pump motor, controller, electrical connections, and other critical components from water damage. This approach enhances the reliability and longevity of the fire pump system, ensuring its availability during a fire emergency. In contrast, the rationale for locating fire pumps below the mean high water level, as suggested in NFPA 13, typically applies to situations where the water source is at a lower elevation, such as a tidal basin or submerged intake. In such cases, positioning the pump closer to the water source can improve suction performance and reduce the likelihood of cavitation, a phenomenon where vapor bubbles form and collapse within the pump, leading to reduced efficiency and potential damage. It's crucial to recognize that the specific requirements outlined in NFPA 20 and NFPA 13 are not necessarily contradictory, but rather tailored to different scenarios and design considerations. The selection of the appropriate pump location should be based on a thorough assessment of the site-specific conditions, including the water source, elevation, flood risk, and hydraulic characteristics of the system. In situations where conflicting requirements exist, consulting with a qualified fire protection engineer and the local authorities having jurisdiction is essential to determine the most suitable approach that meets both the code requirements and the performance objectives of the fire protection system. It is also worth noting that in locations subject to tidal variations, it may be necessary to implement additional measures such as flood barriers or submersible pumps to mitigate the risks associated with fluctuating water levels. Now let's dive into the recommended practices for fire pump installation with a focus on mitigating flood risks. One critical consideration is assessing the potential for storm surge in tidal events when determining the required flood level. Storm surge caused by severe weather conditions such as hurricanes or cyclones can result in abnormally high water levels that exceed normal tidal ranges. Similarly, extreme tidal events, such as spring tides or king tides, can produce unusually high water levels that may inundate low-lying areas. When designing fire pump installations in coastal regions or areas prone to flooding, it is essential to account for these potential surge and tidal events to ensure that the pump and its associated equipment are adequately protected. Historical data, flood maps, and hydrological studies can provide valuable information for estimating the maximum expected flood level at a specific location. Another important practice is to provide adequate drainage around the pump and any emergency generator to prevent flooding. Effective drainage systems can help to quickly remove excess water from the vicinity of the pump, reducing the risk of submersion and water damage. Drainage systems may include features such as grading, swales, culverts, and sump pumps to direct water away from the pump and its critical components. Regular inspection and maintenance of drainage systems are necessary to ensure their proper functioning, especially during periods of heavy rainfall or coastal storms. Installing pumps on an elevated platform or within a flood-resistant enclosure is another recommended practice for mitigating flood risks. Elevating the pump above the anticipated flood level can significantly reduce the risk of submersion and water damage. The platform should be designed to withstand the hydrostatic forces exerted by floodwaters and should be securely anchored to prevent displacement. Flood-resistant enclosures can provide an additional layer of protection by creating a watertight barrier around the pump and its associated equipment. These enclosures are typically constructed of reinforced concrete or other durable materials and are designed to resist the ingress of floodwaters. Protecting electrical components and wiring from water damage is crucial for ensuring the reliable operation of the fire pump system. Electrical components such as motors, controllers, and circuit breakers are particularly vulnerable to water damage, which can lead to corrosion, short circuits, and equipment failure. To mitigate these risks, electrical components should be installed above the anticipated flood level and enclosed in watertight enclosures or cabinets. Wiring should be routed through sealed conduits and connections should be properly insulated to prevent water intrusion. Regular maintenance and testing are essential to ensure that the fire pump is operational in the event of a flood. Periodic inspections should be conducted to check for signs of water damage, corrosion, or other problems. The pump should be tested regularly to verify its performance and ensure that it can deliver the required water flow and pressure. Emergency power systems, such as generators, should also be tested to ensure that they can provide backup power to the pump in the event of a power outage. In addition to these recommended practices, it is important to consult with local building codes and fire regulations, which may impose additional requirements or restrictions regarding the installation of fire pumps in flood-prone areas. Consulting with the local fire marshal or building inspector is advisable to ensure compliance with all applicable codes and regulations. Finally, let's consider the local building codes and fire regulations that may have additional requirements or restrictions regarding the installation of fire pumps on piers. Local building codes and fire regulations often incorporate the requirements of nationally recognized standards such as NFPA 20, NFPA 13, and the IFC. However, they may also include additional provisions that are specific to the local environment and building practices. For example, local codes may specify minimum elevation requirements for fire pumps in flood-prone areas or may require the use of specific types of flood-resistant materials. They may also impose additional testing or inspection requirements to ensure the ongoing reliability of fire pump systems. Consulting with the local fire marshal or building inspector is essential to ensure compliance with all applicable codes and regulations. These officials can provide guidance on the specific requirements that apply to fire pump installations in a particular jurisdiction and can help to ensure that the installation meets the necessary safety standards. In addition to consulting with local authorities, it is also advisable to engage a qualified fire protection engineer to design and oversee the installation of fire pump systems. A fire protection engineer can assess the specific risks and challenges associated with a particular project and can develop a customized solution that meets both the code requirements and the performance objectives of the fire protection system. A fire protection engineer can also provide valuable assistance with the preparation of construction documents, the selection of appropriate equipment, and the coordination of the installation process. By working closely with local authorities and qualified professionals, it is possible to ensure that fire pump installations on piers are designed and installed in a safe, reliable, and code-compliant manner. To summarize, the installation of fire pumps on piers requires careful consideration of various factors, including flood risks, code requirements, and local regulations. By following the recommended practices outlined in this discussion and consulting with qualified professionals, it is possible to design and install fire pump systems that provide reliable fire protection while minimizing the risk of flood damage. Remember to consider the potential for storm surge and tidal events, provide adequate drainage, install pumps on elevated platforms or in flood-resistant enclosures, protect electrical components from water damage, and conduct regular maintenance and testing. These measures will help to ensure that fire pumps on piers are ready to respond effectively in the event of a fire emergency, protecting lives and property from the devastating effects of fire.